the ray model of light. We know that light is a wave, but if the wavelength is much smaller than the object that the light is interacting with, then we can simplify the physics of things and ignore wave effects like diffraction and interference. So how big is the wavelength of visible light? Well, let's look at the wavelength of green light. Green light has a frequency of around 600 terahertz, where 1 terahertz equals 10 to the power of 12 hertz. If we just use the wave equation, lambda equals v on f, where v equals the speed of light, often written as c, equals 3 by 10 to the power of 8 meters per second, then we can calculate that the wavelength of green light equals 3 by 10 to the 8 over 600 by 10 to the 12 equals 5 by 10 to the negative 7 meters. What this means is a lot of the time we can ignore the wave effects of light because the wavelength of visible light is extremely small. In fact, it's only about 0.5 of a micron, where 1 micron equals 1 by 10 to the negative 6 meters. A light ray can be thought of as a line in which the direction along light energy is flowing. So it's not a real thing, it's a conceptual to help us understand and solve problems relating to light. It assumes that the light travels in straight lines, which it does, and it's useful for solving many problems in optics. In this model of light, and in geometric optics, we often define an object, and I think it's worth spending a little bit of time talking about what we mean by an object in this context. An object is often defined as a source of light rays. There's generally two types of objects. There's objects that glow or emit light independently, such as a light globe, a torch, or a candle. Or there's objects that just scatter light, and these most of the objects around us, like yourself, a tree. So objects emit light in all directions, no matter if they glow or scatter. And the light comes from every point on the object and is scattered out radially from that point, like this. The light model that we often see drawn often highlights only a few of these rays, and we do this to define an object's position, generally their top and bottom. But we should remember that there's a whole plethora of rays in between. I really want to emphasize that a ray diagram does not imply that the rays we draw are the only light rays present.